I recently bought this bag of ICs off eBay for about $13, and I thought I would take a look at them and see what kind of interesting chips there are and build up some sample circuits. Now, I'm not an electrical engineer by any stretch of the imagination, really hobbyist at best, but I've always been amazed at these ICs and what they were able to do. And I always thought it'd be cool to get a bunch of them and just breadboard them out, see what types of things that each of them could do, read over some of the data sheets, and really just kind of explore to see what things used to be like long before we had very complicated microcontrollers and microprocessors. So I saw this listing on eBay and I thought, well, what the heck, man? There's a half a pound of ICs, complete grab bag, no guarantees of anything whatsoever that's in them, and I thought it'd be fun to kind of explore it during this series. This is a series of indeterminate length. I'm going to go through as many of these as I can. I'm going to breadboard them. I'm going to build some sample circuits. I'll go through the different data sheets, see what I can figure out about these chips, and where applicable, I will even bring in the Arduino IDE and be able to write some logic in order to kind of control them a little bit better. Now, I have already gone through each and every one of these, and I created a spreadsheet that shows me what the chip is and a link to the datasheet if it was available. So let's go ahead and take a quick look at that eBay listing before we get started. Here's that eBay listing, and it says half a pound lot, IC dip bag, logic, CMOS, TTL, analog, etc. And there's definitely a lot of etc. in there. Now this sold for, I think, $12.34 a piece and $5.50 shipping in the US. The eBay seller is OBLAGON. Not exactly sure what the pronunciation of that should be. I'll put a link to it in the description below, but I have no idea how long this seller has been selling these bags or if they're going to be selling them for much longer. So I don't know if they'll be around if you go take a look at it later. And here's the description of that eBay post. It says listing is approximately half a pound of ICs, a good variety, and it contains all new old stock, no pulls in here whatsoever. It says it lists a few of the things that might be included: TTL, the 7400 series, CMOS, memories, analog, EEPROMs, amplifiers, comparators, IC sockets, microprocessors, and special purpose semiconductors. Mostly dip, although there is some SMD. It's a half a bag of miscellaneous components. And I can tell you it is definitely miscellaneous components. I found some real interesting chips in here. Let's go ahead and take a look at that spreadsheet that I created. So here's that spreadsheet. I'm not going to go through every single item. I currently have it sorted by quantity. So the one that I had the most of was this one here, the TEA 1064A from Philips. And it's a versatile telephone transmission circuit. And I did look at that datasheet because it caught my eye. Plus, there were so many chips in this bag. And this is essentially an entire phone on a chip. So back in the 80s, 90s, early 2000s, if you had a portable 900 megahertz phone or even just one that was corded, there's a really good chance it had this chip in it that did everything. I'm kind of looking forward to taking a look at that a little bit deeper and seeing how much of that circuit we can actually build up. Now, some of these are very straightforward. Obviously, a quad 2-input OR gate. There's nothing fancy about that. And if I scan down here, there's a few others. Here's another OR gate. There's a latch and flip-flop, exclusive OR, some logic. And a lot of these, I have a mediocre knowledge of how they work or what they would be used for, but some of these I have no idea whatsoever. And some of these I've never even messed around with either. So for example, some of these memory ones where they might actually have, whereas right here, this 2 prom, E squared prom. And this is kind of an interesting one where there was no manufacturer listed. 4K bits is what it was listed on the data sheet. So something like this, I'm going to go ahead and take an Arduino and plug it in and see what we can do with it. And there's also a couple others on here that were memory related, and I thought that would be fun to use an Arduino to read and write different memory. Now I'm going to go ahead and start with some of the real simple circuits and kind of build up from there. I don't want to get in over my head too quickly since I don't know exactly how hard it's going to be to get any of these working on the breadboard. And this is the second page of the spreadsheet, and as you can see, these are just onesies chips that I had. And some of these are just completely unknown chips, and I might mess around a little bit with them. I might see if I can't figure something out on them, or I might try to do a deeper search on that and see if I can find anything. But some of them may just be a complete and utter lost cause. But I think a lot of them we're going to be able to do something on. Whether or not they have any practical purposes in today's electronics is unknown. But anyway, that's the project that I'm going to be doing, and we're going to go ahead and get started with some of the very simple circuits. Now I've got them all organized and laid out in these trays. I've got my sheet here printed in alphabetical order, and then these are in alphabetical order as well. There's a few exceptions. I pulled out some of these ones here where I had 17 of these chips. These are these TEA1064A. These are those telephone processor chips. There's just a ton of them. I think there were 17 of them. So I put those a little bit separate. And then I had some of these larger ones that I've just kind of got stuck around. And then I left a couple of gaps here and there so that I can move things around as needed. Now that we've got them all laid out, we can get a better idea of the quantities of each that we've got, and also kind of which ones are maybe a little bit more unique in their packaging or style. It's really hard to see when they're in a big pile. Some of them, like these ones here, have some different leg pitch sizes on them. These are not going to fit in some breadboards. Not exactly sure what we're going to do about those. And then we also have a couple real interesting ones like these up here that have a little clear coat on them, a little window on them. These are EEPROM, or at least this one is, and it's kind of neat. You can see the die on the inside of that chip. And I'm not exactly sure what we're going to do with this one. It is a ceramic. You can feel it. It feels a lot different than some of the other ones, and it's just got a real nice feel to it. It doesn't have that epoxy feel. You can tell that's a ceramic. And then this one over here, which again, I'm not entirely sure what this one is. It's got a really glossy finish on it. It's not ceramic. It's some type of a plastic or epoxy on it, but it's just got a real interesting feel on it. I'm gonna have to do some more research and see if I can find any information on this. One of the things is it's got 4 different rows of text on it, and I'm not entirely sure which one is the part number and what might just be some other data that's not super relevant. Now out of these, there are quite a few of the 7/4 logic, which will be pretty easy to go through. That's pretty common. You can find a lot of information on those online. And there's also a whole bunch of flip-flops, which are used on the data bus, back in the old computers, back before they had super fast computers. And we're going to take a look at those as well. I think there's 4 or 5 different flip-flops in here from different manufacturers. Some have some slightly different specs on them as well. We've got some little guys like this in this 8-pin DIP package, and this says it's a 4K bit serial E² PROM, which I guess I don't know if that's entirely true. I got to look deeper into the data sheet on that. When I was pulling up the information, I largely would just make it match on the serial number, note what it was on the spreadsheet, download the PDF file if there was one available, and move on. So I haven't had a chance to look at them, but that's kind of an interesting small little package if that's true. This one here says it's a triple 2-input exclusive OR, exclusive not OR, which I've never seen before, but I don't know, maybe it was really, really popular back on some of the early 8-bit computers. But I'm kind of interested to see how that package is worked out on the die and how that works and what some practical uses for having both of those on the same chip might be. So this one here isn't a mystery. This is a quad op amp, which we've seen in many different packages. I didn't recognize this name or this manufacturer at all, so it'll be interesting to take a look at the data sheet and see how that varies from some of the more commonly available op amps that we might be using today. Then we get this little guy here. This is in a little surface mount package, which we're definitely not going to mess around with. Plus, it's not that interesting. This right here is a 10-bit D-type flip-flop with positive edge trigger. I've got a whole bunch of other flip-flops in here as well, and I'm not going to mess around trying to get something rigged up so that we can actually hook some leads up to this surface mount guy. But anyway, kind of a cute little package. Then I got a couple of these really large ones, kind of an interesting little package. I was unable to find a data sheet for this, and it's a nice little ceramic package. And it's interesting, if you look at the leads on this, it kind of looks like they've been tinned. So this might have actually been a pull instead of an original one. This might have been pulled out of an existing board. And it is marked Philippines on the bottom, but I don't know what it is. I'm assuming it's some type of a memory or microprocessor of some sorts. I'll try to find out if I can find some other information on any of those numbers online. I think this right here is a little PIC processor. It says it's a EEPROM ROM-based 8-bit CMOS microcontroller, which I don't have any experience at all with the PIC microcontroller, so it'll be interesting to see if I can figure anything out on these guys. I've got, let's see, it looks like there's 5 of them as well. So there's everything all nicely laid out and organized for us to get started. Now I'm going to start off with some of the easier ones, and then hopefully we'll progress into the more complicated ones, and then maybe do some additional research on some of the more complicated ones. I think I'm going to start with some of the flip-flops, since I've got a bunch of those, and they're honestly not that interesting, but there's something that we can go ahead and take a quick look and start to figure out how we can process some of the information that's available on the data sheets, but then also start to put these into a breadboard. So anyway, hope to see you along the journey.